Right. Oh, so let's do this question, guys. This question in one. It's from June 2026, paper 3. It's about oscillations. So as you can see here, the vibrations of a component in a machine is represented by the equation x is equals to 0,3 times 10 to the power minus 4 sine what, where x is displacement in meters. So what this equation here, relationship between displacement and what, and time. So as you can see, the equation that we are given is written in the form x is equal to x naught sine omega t. Those are the ones that whenever you see an equation like this, you want to kuziva the original form the equation, right? In this case, the original form of this equation is x is equal to x naught sine omega t. Why is it important for you to know the original form? Because you will need to compare. When I'm saying you will need to compare, the original equation really x is equal to x naught sine omega t. Compare. This one is the given equation. This one is the original equation. So when I'm saying we have to compare, I'm simply saying tikatarisa sine panapa ndo sine panapa, tikatarisa t panapa ndio t panapa, kureva kuti 240 pi ndo iri equivalent to omega. So here I can come here and say omega is equal to 240 pi. Omega, we all know that this is the angular frequency, which is measured in radians per second. And then x naught ndio 0,3 times 10 to the power minus 4. So x naught is equals to 0,3 times 10 to the power of minus 4. X naught chi, x naught no amplitude, maximum displacement. So our first question is sketch a graph of displacement against time. Graph of displacement against time are because relationship between displacement and time no equation ratakapuwa. So iwo chonofana kugona recognize chekutanga kuti graph is a sine function because pana sine there. So you are simply drawing the graph of what? The graph of sine. So to result graph of sine, right? Then this one is our horizontal axis. So what we are going to do is we are going to check it. We are drawing the graph of what? Of displacement. What displacement there? This is our vertical axis. And then this side we are going to put time, not x. Here we are going to put time. And this is the graph of sine, guys. Graph of sine, not a graph of origin. And then it goes like this. It goes like this. So, question yakaita se examiner asikuda ngotongodwa graph chete. The other thing examiner chandaona anda kuona atinoti isusu ma critical values. When I'm talking about my critical values, because my values are important for graph rako. Number 1, a period. Period, remember, is the time taken for one complete oscillation. So if you know this right period, pana time up and down, what is right values? Value you unayoiona kupi? Unayoiona oku. You are defined to omega and 240 pi. So we are going to take that equation here and then we are going to bring it down. So omega is equal to 240 pi. So remember that omega is the same as 2 pi over period, 2 pi over t. So this is equal to 240 pi. And we can solve this equation to know the value of t. How? We can cancel pi from both sides. And then we cross multiply. We are going to have 2 is equal to 240 t. We divide both sides by t. And then we are going to know the value of we divide both sides by 240. We divide both sides by 240. So 2 over 240. This is equal to t. What is the value of t? Let's press our calculators. So the value of t is I'm getting t being equals to 8.33 times 10 to the power of minus 3 seconds. Kuroti pagraph rako pano apa toda kuona wakanyora value iyoyo 8.33, and here what is going to be the value? Tongotora 8.33 iyo 12 times under 2. Let me do that, multiplied by 2, and my calculator is giving me 16.3. So panapa I'm going to say time yangu iri in terms of times 10 to the power of minus 3 seconds here. Right. And then the other thing is to graph amplitude, which is the maximum displacement. If you go back here, you are going to see that our maximum displacement is 0.3 times 10 to the power minus 4. So here you can write 0.3, and then here you can write minus 0.3. So panapa my values are x hour, they are times 10 to the power minus 4 meters. So this is the graph, guys, for what? For item 1, which is displacement versus time. We don't draw it nice so graph ready. Right, let's go to item 2. Calculate the acceleration at maximum displacement. We all know that when we are talking about simple harmonic motion, acceleration is equal to negative omega squared x. So this is the formula for acceleration, right? So apa tifanongotinetsa apa totouya tototi isusu kwanzi tiri kuda maximum acceleration. So from this relationship here we can simply see that acceleration is directly proportional to x. Kureva kuti kana uchida maximum acceleration here, even this displacement must be maximum. So let's modify our formula here. We are going to say we want a max. So a max is equals to negative omega squared by x max. And let's substitute my values. Edu omega tinaye is 240 pi. Value omega t defined of data 240 pi. This is omega squared times x naught. X naught is our maximum amplitude, maximum displacement, which is the amplitude. So 0.3 times 10 to the power of minus 4. 0.3 times 10 to the power of minus 4. And then we are going to know our maximum acceleration. It's going to be negative here. If I press my calculator, the value that I am getting is 17.05 meters per square second. So this is the maximum acceleration. This is the maximum acceleration. It's all about you knowing the definition of simple harmonic motion, because equation ireri ndo ratinoti simple harmonic motion ireri. Sketch a graph of acceleration against displacement. Sketch a graph of acceleration against displacement. Right. Okay. So let's plot. We have our vertical axis and we have our horizontal axis. So I want to plot the graph of acceleration versus displacement, and the displacement, right, is going to be times 10 to the power minus 4 meters, and our acceleration is going to be in meters per square seconds. So from this relationship here, the total of acceleration and the displacement, these two are directly proportional. Once we say they are directly proportional, it means that the graph redu anditika rinofana kunge iro really straight line that passes through the origin. And then because of this negative sign here, which is actually there, because we know that acceleration is always directed towards the equilibrium. And we also know that acceleration and displacement are in opposite direction when we are talking about simple harmonic motion. So graph redu rinofana kunge in a negative gradient, meaning that we are going to have a straight line like this, right? So this is going to be our graph for acceleration versus displacement. Here we have 0, well, this is the equilibrium position, and we are supposed to draw the graph of acceleration against displacement. So let us put the values. Every time you want to draw a graph, unofanira kutoisa ma values aya, because examiner ndo ma values anenge achitotarisa iwawa achida kuona kuti unoziva here zvinotarisirwa. So here we have 17.05, and the displacement that corresponds to this point is actually going to be minus 0.3 times 10 to the power minus 4 taisa kudhara kuno 0.3 iyi ndo maximum displacement yedu inova yo amplitude. Same nokuno 0.3 here times 10 to the power minus 4, and our acceleration is going to be negative 17.05. So ndo zvine zvakaita graph redu izvi. Right. Use the graph of acceleration against displacement. Iri graph rawadrowa panapa. What are you supposed to use this graph for? To explain the simple harmonic motion. So when you are looking at this graph, how can you explain a simple harmonic motion? I was going to say, when I'm looking at this graph, acceleration is directly proportional to displacement. This is what I'm seeing from the graph number 1. Number 2, what else are you seeing here? Acceleration and displacement are in opposite direction. Because of that negative sign there, are in opposite direction. Right? Then point number 3, I was going to say acceleration is always directed towards the equilibrium. Right? But here there's something that you have to see. Why that acceleration and the displacement, they are directly proportional? Because upon a straight line. Why am I emphasizing on this one? Because question yako yachi nizo. Use your graph. So you must justify kuti chaita kuti ugopa conclusion iyi yekuti acceleration and displacement is really directly proportional. Inyaya yekuti graph redu is straightward line that passes through the origin. And then chaita kuti tigoti acceleration and displacement are in opposite direction. Inyaya yekuti graph redu rine negative slope kana kuti rine negative gradient. Are we together, learners?